set it equal to 0. And we move forward, so this will be negative 4 over 6. We simplify into negative 2/3. So that's the only critical number I don't need that. The only critical number that this function has. Can critical numbers come from f prime being undefined?
No.
No, it's a polynomial. Thank you very much. Good, so I put in the table negative 2/3. And 0 for the derivative, but that's what it is. The derivative is 0 at negative 2/3. Immediately I have to punch in the function, this number. This is the function. I want to punch this number in here to get the y value of this. So, I'm going to share my screen. I'm going to put this in. It's just a habit, as you know. 3x squared. I didn't mean that. 3x squared, that's what I meant, plus 4x and plus 2. And then I plug in negative 2/3.
Positive 2/3.
When I move forward to the other side, I get negative 4. Negative 4 over 6 will be negative 2/3. And look at that.
I meant the answer was positive.
Oh, yes, yes, yes. Thank you. Thank you. You're way ahead of me. Thank you so much. Awesome. Thank you. It is 2/3. Good. At this point, I need to study the sign of the first derivative. Please plug in something to the left of negative 2/3, like negative 10, in here. And positive or 0. 0 is fine. You don't really need, this is a linear function. You know it looks like this. You know what the sign will be and where the sign will go. But you don't have to. Plug in negative 10 and tell me the sign. Plug in 0 and tell me the sign.
262 is positive.
So which part?
Negative 10 is positive.
Excellent. Perfect. Good. So then, now when I plug this negative, I know that this function looks like this, right? So when I plug in negative infinity, this will be infinity, and then here will be infinity. I need to determine these, right?
Professor?
Yes?
Wasn't it positive when you stuck in negative 10? I got like positive 262. So would it be a plus sign on the left of the 0 or no?
Yeah, that's what I was going to say.
I got negative 56 for negative 10 because I plugged in 6x plus 4.
Of course. We're talking about the first derivative. The first derivative is a linear function with a positive slope. It has to be negative and positive. There's no discussion there.
Sorry, I put it into the original.
We're talking about the derivative. Be very careful. This is the derivative, and this is the function. Good. So from positive infinity, you can punch in the function positive infinity, and you know this is infinity. And when you punch in negative infinity, it's still infinity, right? Because we know that when we talk about infinities, these two do not count. These two are too small to mention. And when I punch in here negative infinity, I get positive infinity. When I punch in infinity, I get positive infinity. No question. Now, I need to make sure that these two rows work well together. Do they? I don't know. Let's give it a shot. From positive infinity to 2/3, what does the function do?
It's negative. It goes down.
Very good. It's not negative. The derivative is negative.
Or it has a negative slope.
Exactly. So from positive infinity to 2/3, the function is decreasing. Is that supported by the sign of the first derivative? Is that action supported by the sign of the first derivative?
Yes.
Perfect. From 2/3 to infinity, what does the function do?
increases.
Very good. Is that supported by the sign of the first derivative?
Yes.
Perfect. So we know that this point, negative 2/3, comma 2/3, is what type of point? And I have to write it right here next to it.
A minimum.
Very good. Awesome. So this is a relative minimum. Negative 2/3, comma 2/3. Okay, at this point, we have to deal with the second derivative. Can anyone give us the second derivative?
6.
Excellent. Is this ever 0?
No,
It's a silly question. What is the sign of 6?
it's undefined though. Right?
What is the sign of 6? Nothing is undefined if it's a
Positive.
constant. It cannot be undefined if it's a constant.
No.
So if the second derivative is always positive, is the function concave upward or concave downward?
Upward.
Very good. Now, if the function is concave upward, and this is what it's called the second derivative test. So we don't know what the sign is. So I'm asking you now, if the second derivative is positive, this point, negative 2/3, comma 2/3, what type of point can it be? I don't know the sign of the first derivative. I didn't study the sign of the first derivative. But I have the second derivative and I know that it's positive. What type of point will negative 2/3, comma 2/3 be if the function has to look like this?
It has to be a minimum because it's at the bottom.
Exactly. It has to be a relative minimum. So but if I don't have this information that this is a critical number, then I cannot conclude anything, right? But, so see how important this table is. It tells me how the function looks like. It tells me when it's decreasing. It tells me when it's increasing. And it also gives me this point that is the relative minimum. This is also an absolute minimum because there is nothing smaller than it. Comes from positive infinity, drops to 2/3, goes to positive infinity. Any questions on this? Because I like to look. Yes?
Sorry, as we're doing these and I know you're assigning things and you're telling us not to do the graphing when we do the written homework.
We will graph, but not yet. I just want to emphasize the table and then we will graph.
Today or?
If we have time today, but I need to show another table without graphing.
So we won't have homework on my lab math that tells us to graph until.
In my lab math, you may be asked to choose a graph, which choosing a graph is not graphing.
Yep.
Yeah, that's not graphing.
Is this what we're uploading for tonight?
Yes, if you'd like to, that's good. I'll wait for that.
Just this problem for the upload?
Just this problem. And then I would like to look at a word problem, but I like to work on another table. How do you feel about the table? See, now I can answer all the questions. Oh, let me wait for you to upload and then I'll explain more.
Can we do one more with the table?
Of course, absolutely. That's why I don't want to continue with the graph just yet. I don't want to jump into graphing before I show more of this. Of course. Yes, of course. Once we understand the table, graphing will be a piece of cake. If we don't understand the table, graphing will be very difficult. Let me know if I have to wait longer. Is this okay? Are we okay? Can I continue? I think I have a chat. No? Can I continue?
Professor, upload, right?
Yes, upload for today.
Okay.
Do you need more time?
I'm okay, but I don't know about everybody else.
You can fix me. I'm
Okay.
good.
Okay, so let's come back to the table and let me say a few things. How do I answer all those questions that we read together a second ago? Very simple. The function is decreasing for x between negative infinity and negative 2/3. The function is increasing for x between negative 2/3 and infinity. The function does not have an inflection point. The function is always concave upward on all its domain from negative infinity to infinity. The function has a relative minimum, and the point is negative 2/3, 2/3. Everything is here. Now, you understand why the function is in the middle. So I can read this way. You can swap these two if you want, or you can swap these two, but it will be slightly more difficult. If you keep the function in the middle, you will have the information like this, and when we get to graph, hopefully today, or if not definitely on Wednesday, you have all the information like this. You don't have to jump over rows. Okay, the same question here. What is the question? Everything. Increasing, decreasing, max, min, concavity, inflection points, everything that I know it's already in the table. So I'm going to move on to the next page because I don't have enough room here. So that's page 8. So this is f of x, e to 3x minus e to x. These problems get more and more difficult. They're not easy. So a quadratic function is one thing, exponential, rational, logarithmic, are different things. So f prime of x, f of x, and the second derivative. Okay. Can anyone give us the domain of this function? That's our first step. A difference of exponentials. What could the domain be?
Negative infinity, positive infinity.
Thank you very much. No problems, thank you. Very good. Also, I would like to discuss these limits here. They're very important. So what is the limit of e to 3x minus e to the x power as x approaches infinity? As x approaches infinity, this will approach infinity and this will approach infinity. Please do not say 0, because infinity minus infinity is an indeterminate case. But as x approaches infinity, which of these two will be stronger? Which of these two will go to infinity faster?
E to the 3x.
Very good. Exactly. So then this must be infinity. That's not what I meant. I meant to write it here. Sorry about that. Okay, now I have to determine this. Limit as x approaches negative infinity from e to 3x minus e to x. So let's take it step by step. As x approaches negative infinity, e to negative infinity, where is this going? Because negative infinity times 3 is negative infinity. Where is this going? you have to picture this as e to a negative number as this. If you don't picture this, then it will be more difficult to state the answer.
Closer to 0.
Excellent. So this approaches 0. Very good. What about this one?
To infinity. Negative infinity.
It's the same thing. It's the same thing. It's still e to negative infinity. It's still 1 over e to infinity, and it's still the same thing. It doesn't matter if it's 3 or 4 or 1. As long as x approaches negative infinity, it's the same concept. So this is 0, which means y equals 0, horizontal asymptote, at negative infinity only. So that is 0. Good. So we established that. So now we have to look at the first derivative. These are very cumbersome situations. A lot of work on these problems. So we have e to 3x minus e to x. Let me write it here one more time. E to 3x minus e to x. So can anyone give us the derivative of this?